Hi everybody. Today we're going to look at simplifying algebraic fractions. Hopefully this is something that comes easy to you and we can quickly move on to solving. So the three things that we want to be able to revise and check on is, can we expand brackets using distributive law? Do we understand what the concept of simplest form is? And to make sure that you can actually simplify an algebraic fraction. So let's have a look at some simple cases to start with. Here's a bracketed expression and we need to be able to expand it. So we're going to multiply 2 by x and 2 by 4. So 2 by x is 2x, whoops, and 2 by 4 is 8. The common mistake is to forget to multiply that by 2. So in this case we have negative 3x multiplied by x minus y. So minus 3x times x is minus 3x squared, and minus 3x times minus y is positive 3xy. And the mistake often being is to forget to multiply the two negative signs to make a positive one. In a larger expression, we would have 3x plus 6 take, oops, let's write that properly. 2 times 4 is 8x, negative 4 times negative 4 is positive 16. Collecting like terms, 3 take 8 would be negative 5x, 6 plus 16 would be 32. Would it be 32? No, it wouldn't be 22. Okay, starting bit done. Let's move towards our what should I say? Let's just have a look at adding two fractions together. Nothing very complicated. They're unlike terms, not unlike, the denominators aren't common, so we should make them common. To do that, we're going to multiply the second term by 2 on 2. That will give this a denominator of 4 and give that a denominator of 4. So that will be 3 plus 18 over, let's make this a bit nicer, over 4, which will be 21 on 4. Let's have a look at the next one. Now we've got denominators of a and 2. The common denominator will be 2a, so we'll multiply this by a on a. And we'll multiply this by 2 on 2, which will give us 4 on 2a plus a on 2a, which is simply 4 plus a on 2a. Finished. Okay. Now, sometimes we'll have to multiply, so let's write this as if they're being multiplied together. You'll get 2 brackets a plus 2 on 4a. Now we could split this into 2 on 4 times by a plus 2 on a, which will give us a half times a plus 2 on a, which is simply a plus 2 on 2a. Now, those of you that are used to cancelling, we could of course cancelled it here and written that as a plus 2 on 2a directly in that step. But I didn't do that because I'm trying to illustrate why things work, not just how they work. So let's do some questions together. 2 on 3 take 1 on 6. The common denominator would be 6, so I'm going to multiply this side by 2 over 2, which will give me 4 take 1 on 6, which will be 3 over 6, which is simply a half. Instead of multiplying, we're dividing in this case. In that case, you would take the reciprocal of the second term. So 4 on 7 multiplied by 7 on 2. Take the reciprocal and multiply when you're dividing. So turn that upside down, change that to multiplied. 7 fours are 28 on 14, which would be 2. Now we could have gotten to that by cancelling. 1 here. That and that will be 1. That will cancel down to 2. That will cancel down to 1. 2 times 1 gives on 1 is simply 2. But there is no, as always, there's no point in doing that if you don't know what you're doing. So there we go. Find the reciprocal. As previously stated, the reciprocal is just turning it upside down. Putting the denominator as the numerator and the numerator as the denominator. Finding the lowest common denominator of these two terms. Well, if we looked at the multiples of 3 and 4, 3, 6, 9, 12, 4, 8, 12. The lowest common denominator of 3 and 4 is 12. It's important that we answer the question that we're given. It said find the LCD, so we should state the LCD. Simplify by cancelling common factors. Okay, so here we go. If we have 10 on 2 times x on 1, we can cancel these. That becomes 5. That becomes 1. 2 goes into 10 5 times. 2 goes into 2 once. And once we've done that, we know that the answer is going to be 5x. In this case, we'll end up with negative 36 on 4 times by a on a times by b squared on b. That will cancel down to 9 fours are 36, 1 on the bottom. These will cancel out to just be 1. That will cancel with that. So we will end up with 9b. This one's quite a clever one. It requires you to factorize first. So if we factorize 4 out of our numerator, now we can split this into 4 on 4 times x plus 2 on 1, which will leave us with just x plus 2. As these will cancel out, and you'll end up with 1 on 1. 1 times x plus 2 is just x plus 2. We can do something a bit clever here. When we multiply, order is not important. So I can put the x take 1 on x and multiply by the 3 on 6. 3 on 6 is simply a half. You end up with x take 1 on 2x. Here's multiply and find the reciprocal again. So x on 15 multiplied by 15 on x. As before, the x's will cancel. That will become 1. 3 goes into 15 3 times. We end up with just 3. In this case, we need to find a common denominator. The common denominator will be 21. Multiply this by 3 on 3. That gives us our denominator of 21. Multiply this by 7 on 7. That gives us 15 plus 3a on 21. As 3 doesn't go into 14, we can't simplify any further. Similarly, with this case, the common denominator will be 20. The lowest number 4 and 5 will go into is 20. So multiply this side by 5 on 5. Multiply this side by 4 on 4. So we end up with 5 times x plus 3 plus 4 times x plus 2 all over 20. Simplifying each bracket, 5x plus 15 plus 4x plus 8 over 20 will give us 9x plus 23 over 20. Similarly with this one, we're going to multiply, we're going to have a denominator of x plus 1, x plus 4. So we'll multiply this part by x plus 4. On x plus 4. And we'll multiply this side by x plus 1 on x plus 1. And we'll end up with 5x plus 4 plus 2x plus 1 over the common denominator of x plus 1, x plus 4, which will simplify to 5x plus 20 plus 2x plus 2 all over x plus 1, x plus 4, which gives us 7x plus 22 on x plus 1, x plus 4. There's no common factor of these two terms, so we can't simplify any further. Okay, the LCD of 3 on a and a squared, well, that's going to be a squared, because a squared, we start with a, next one will be a squared. A goes into a squared a times. Quite an interesting exercise that. I hope that was helpful, and I'll see you next class. Bye.